These two are given to be parallel. Okay, and center is given to be O, and this angle is given to be 25 degree, angle ABC. Okay, you need to calculate the value of angle CED. Which one is the angle CED? This one. This red one is CED. So how will you calculate? This is again a little twisted problem. Okay. Now what you do here is, first of all, you see that this 25 degree angle that is given, it is on which segment? If you join this with the help of a very light line, let us say, if you join this chord here, okay, then this chord divides it into major segment and the minor segment. So this angle is actually on which chord? AC, and it is in the major segment. Is there any other angle that you can see on chord AC in the major segment? Can you see any other angle? I can't see. So angles on the same segment will not work here. Okay, so therefore, but if you see, center is given, but which one is the angle at the center? So what you do here is you join OC and you join OD. Okay, once you join OC and once you join OD, what you see here is this 25 degree is the angle subtended by the remaining part of the circle, and what is the angle subtended by this arc AC at the center? It is this, right? And this 25 degree is the angle subtended by the remaining part of the circle. So therefore this angle AOC, this angle must be double of 25, which is 50 degree. Okay, this is first thing. Second thing that you must notice here is that this 25 degree and this 25 degree are alternate angles, right? These are alternate angles. Do you agree or not?
Sir,
Alternate
how
angles.
50 came?
How 50 came? Because if you see, what is the angle subtended by the arc AC at the center? This angle, right? AOC, right or wrong?
Yes, sir.
What is the angle subtended on the remaining part of the circle? 25 degree, right?
Oh, yes, sir. Yes, sir. Understood.
So therefore, the angle at the center must be double the angle on the circumference, right? So this is 50 degree. Next, these two are alternate angles, 25 and 25. This was what I was asking. Do you agree these two are alternate angles? Because AB is parallel to CD. AB, CD. This angle is given to be 25. These two are parallel. Therefore, this should be 25. That is what I have done. Okay, so angle BCD is 25 in the diagram. But what you also see is that angle BCD is the angle subtended at the circumference, 25. What is the angle subtended by this arc BD at the center? It is this. Therefore, this should be double of 25. This should also be 50, right? So I've calculated two angles. So what should be this angle? COD. What should be this angle? 180 minus 50 minus 50, because the angles on the same straight line. So this angle should be 180 minus 50 minus 50. This should be 80. Now how will you determine the red angle? Can you see a relation between 80 degree and this red angle? What is this 80 degree
Yes,
angle?
sir.
80 degree angle is the angle subtended by this arc CD at the
On the
center.
center of the circle.
And this red angle is the angle subtended at the circumference. So this angle should be half. So if this is 80, this should be 40. So that is what is required here. Okay, so what we'll write here is, we start by saying join OC and OD. Okay, so therefore we'll write angle AOC is twice of angle ABC, which is 2 into 50. Or maybe I can give the reason here first. Now I will write 2 into 50, twice of angle ABC, because angle subtended by an arc at the center is double the angle subtended by it on the remaining part of the circle. So this is 2 into 25, which is 50 degree. Next, the alternate angle part. Angle ABC is equal to angle BCD is equal to 25 degree. Why? Because they are alternate angles. Okay. So therefore, what is angle BOD? BOD is twice of angle BCD. Again, same reason, angle subtended by an arc at the center is double the angle subtended by it on the remaining part of the circle. So this is again 2 into 25, which is 50 degree. So two angles we have found out. Which two angles we have found out? This angle 50 and this angle 50. So now we are proceeding to find out this angle. They all three, if you see the blue marked angles, all the three angles are angle on a straight line. So therefore, what is this angle? This angle, the 80 degree angle that I have marked in the diagram, that is angle COD. Angle COD is equal to 180 minus 50 minus 50, which is equal to 80 degree, because they are angles on a straight line. Angles on a straight line. So it's 80 degree. So therefore, what is the red marked angle here? If this angle that we have got as 80 degree, this angle is the angle subtended by CD at the center. So therefore, it should be double the angle subtended at the circumference. So the red angle must be half of 80. Therefore, we write angle CED, the red one, angle CED is equal to half of angle COD. Reason same, angle subtended by an arc at the center is double the angle subtended by it on the remaining part of the circle. On the remaining part of the circle. So half of COD, half COD we have found as 80 degree. So this is 40 degree. And this is the angle that we wanted to find out, angle CED. Okay. So that is what. Let's move on to the next question. Let's draw the diagram for this. And this is joined with the help of a dotted line. Yeah. And here the vertices are given as ABC of the triangle DE. And what else is given? That this side is equal to this side is equal to CD. Okay. And the question here is, and also what is given is ADC is equal to 38 degree. Let us mark what is given.
अलग है ना इसमें आता है कॉल ओवर इंटरनेट और नीचे का देखो सब अलग अलग सिंबल्स है यहाँ पर.
This is given to be 38 degree. Okay. You need to calculate angle ABC first. So angle that you need to calculate here is this red angle. This red angle you need to calculate. And the second part, you also need to calculate angle BEC. BEC is this angle. So these two angles you need to calculate. Okay. Now for the first part, there is no theorem on circles that is required for the first part. Something that is very easy. Look at this triangle ACD. Can you see this triangle? In this triangle ACD, side AC is equal to side CD, right? Therefore, the angles opposite to equal sides must be equal. In an isosceles triangle, the angles opposite to equal sides are equal. So which two angles are equal? Opposite to the side AC is 38 degree and opposite to the side CD is this angle. So this must also be 38, because you know that in an isosceles triangle, opposite to equal sides, angles opposite to equal sides are equal. Once you have calculated these two angles, you see that these two angles are the interior opposite to this angle. So this angle will be 38 plus 38, because if you consider this triangle on this, but if you consider the same triangle ACD, two angles 38 and 38, these two are interior opposite angles. Okay. And interior opposite to which angle? This 38 plus 38 that I have marked. Interior opposite to this angle. So this you get as 76. Now if you look at this triangle ABC, the side AB and AC are equal. Therefore, again, if you apply that theorem that angles opposite to equal sides are equal, you can say that if this angle is 76, this must also be 76. So that is done. So I will answer the first part of the question. I will write triangle ACD is isosceles in which AC is equal to CD. Okay. That means angle opposite to AC is which angle? Angle ADC. And opposite to CD is which angle? Angle DAC is equal to 38 degrees. Both these are 38, and the reason is in an isosceles triangle, angles opposite to equal sides are equal. Okay. So I've got these two as 38. So now I'll now find this angle, which is the exterior angle of triangle ACD. Also, I'll write angle ACB is equal to 38 plus 38, which is equal to 76 degree, because exterior angle of, let's mention the triangle of triangle ACD is equal to its interior opposite angles. Okay. Now we consider the triangle ABC, the triangle that is inside the circle, ABC. If you see in this ABC, AB is equal to AC, so therefore angles opposite to this, these two sides must be equal. So triangle ABC is isosceles in which AB is equal to AC. That means which two angles are equal? If AB is equal to AC, then angle A, what is the angle opposite to AB? ACB. And what is the angle opposite to AC? It is ABC. So ACB is equal to angle ABC. And ACB we have already found above to be 76 degree. So that is what your answer to the first question is. Your first question was find the value of angle ABC. We have calculated ABC to be 76 degree. The red angle has been calculated. Okay, now the question is how to calculate the blue angle. That is angle BEC. Okay. Now if you see this blue angle here, this BEC and this angle, they are equal. Can we say that they are equal? And if so, then why? Can someone say why they are equal? Can anyone say why they are equal?
Sir, which one?
The two blue marked angles, the two angles that I have
Yes,
marked
sir,
in blue.
because BC, they are on the major segment from the chord BC.
Yes, they are on the same segment. They are on the same segment. If you see this chord BC divides it into this segment, minor segment, and this major segment. Okay, and if you see this angle, this blue angle BAC is on the chord BC. Also, it is on the chord, this blue angle here, this is also on the chord BC, and they are both in the major segments. So therefore, they must be equal. The second part is just a cakewalk. Angle BEC is equal to angle BAC. Angle BEC is equal to angle PAC or before that I have to calculate BAC. So we will calculate BAC. How will you calculate BAC? How will you calculate this angle? If you consider triangle ABC, these two angles you know, 76 and 76. Therefore, you can calculate the third angle. And once you calculate this, you get the value of BEC. We will first proceed to calculate angle BAC. In triangle ABC, angle BAC, the unknown angle that we need to calculate, plus angle ABC plus angle ACB. Is equal to 180 because sum of interior angles of a triangle is 180 degree. Angle BAC plus 76 plus 76 must be equal to 180. Means angle BAC plus 152 is equal to 180. That means what is angle BAC? It is 180 minus 152. So this is 28 degree. So we have managed to find out the unknown angle, that is this angle here, angle we have found out. So when we know this angle is equal to this angle, because they are angles on the same segment, we will simply write angle BEC is equal to angle BAC. Hence, angle BEC is equal to angle BAC is equal to 28 degree, because angles on the same segment are equal. Okay, so this is how you do this sum. Next sum, interesting one. In the figure given below, diagonals of a cyclic quadrilateral ABCD intersect at P. What do you mean by a cyclic quadrilateral? Any quadrilateral whose four vertices lie on the circle is called a cyclic quadrilateral. I will mention this in detail after this also. Okay. Because after this we will be dealing with cyclic properties only. In this I will be discussing your cyclic quadrilaterals. So A, P, D, C and B. Okay, this is the figure given. It is given to you that ABCD is a cyclic quadrilateral. Cyclic quadrilateral means if you see this vertex A here, this vertex lies on a circle. This vertex B lies on the circle. C lies on the circle and D also lies on the circle. Okay, so all the vertices of ABCD, quadrilateral ABCD, lie on the same circle. Such a quadrilateral is called cyclic quadrilateral. Although we will not be applying the concept of cyclic quadrilateral in this, they have given you this just to confuse. Okay, diagonals of a cyclic quadrilateral ABCD intersect at P. What are the diagonals of the cyclic quadrilateral? The diagonal BD and AC. They intersect at P. And the area of triangle APB is 24 centimeters square. This area is given to be 24 centimeters square. Okay. If AB is equal to 8, so here this is given to be 8 centimeters. CD is 5. This is given to be 5 centimeters. Calculate the area of angle DPC. Triangle DPC. This area of this triangle you need to calculate. Now, if you see in this figure, the area of triangle is given, the side of the triangle is given. So tell me, what is how do you relate areas with sides? Can anyone tell me how you relate area with sides? How is area and sides related? How are area and sides related? Can anyone tell me? I just finished this chapter. Area and sides related, how?
Sir, it is directly proportional.
Directly proportional. Directly proportional to what?
Means half into base into height. So if
No,
height
no, no,
increases,
absolutely wrong. Absolutely wrong. Shazia, can you tell me?
Sir, area of triangle ABC, ABP by area of triangle DPC is equals to AP square by DP square
Why?
or any other side square.
Why?
So we have to prove. A triangle APB and DPC similar.
Exactly, similarity. The answer to my question was simple, similarity. The concept that links area of triangles to its side is similarity, area of two triangles to its sides. So if I can prove that this triangle, wait, um, if I can prove that this triangle, red tick triangle, and this triangle are similar, then I can say that area of this triangle by area of this triangle is equal to square of the proportional sides, right? But how do I prove similarity? Before writing, I will not write this. First, let us understand how to prove similarity. This is a very, very important proof. How to prove similarity? First of all, these two angles are equal. This angle is equal to this angle. Why? Because they are angles on the same segment. Consider the chord AD. Consider chord AD. This chord AD, divide this into this minor segment and the major segment. If you see these two angles, these two blue angles are on the same major segment. So therefore they must be equal. They are on the chord AD and they are on the major segment. So therefore they must be equal. And you can say these two angles are vertically opposite angles. Therefore, for these two triangles, I have shown that the two angles are equal. Therefore, they must be similar by angle-angle rule. Any questions on similarity? Any questions on similarity?
no, sir.
These two angles are equal. This blue angles here. These two blue angles, they are equal because they are angles on the same segment. If you see, they are angles on the chord AD and they lie on the major segment. So therefore, they must be equal. Also, the green angles here, they are vertically opposite angles. Therefore, if you see from this triangle and this triangle, I have shown that two angles are equal. And if two angles are equal in two triangles, then we can say that they are similar by angle-angle rule. Okay. Now you can write the proportional sides, and then you can also find a relation between the area of the triangles. Okay. So I stop here. for today.